Alright, so now let's look at another example. So, according to the Census Bureau, 3.14 people reside in a typical household. We have a sample of 20 households in Arizona retirement communities, and the sample showed the mean number of residents per household of 2.82. The standard deviation of the sample was 1.11. At the 10% or 0.1 significance level, is it reasonable to conclude that the mean number of residents in the retirement community household is less than 3.14? Okay? So now in step one, what we want to do is we want to develop the null and the alternative hypotheses, right? Okay. So remember again that the alternative hypothesis is whatever we want to show to be correct, right? Whatever we support. So in this problem, what we want to do is we want to conclude that the mean number of residents is less than 3.14. And so that will go into our alternative hypotheses. So in the alternative hypothesis, mu is going to be less than 3.14. And so in the null, we're going to have mu being greater than or equal to 3.14. Okay? And just by looking at these hypotheses, you can tell that this is a lower tail test. Okay? And the reason I know this is a lower tail test is because we have the less than sign in the alternative hypothesis. Okay. So now in step two, we want to calculate the test statistic. Okay. So again, in this problem, we are not given the population standard deviation, but we are given the standard deviation of the sample. Okay, so our test statistic is going to be t, which is going to be equal to x bar minus mu sub 0 divided by sx over the square root of n. X bar is the sample mean, is 2.82. Mu sub 0 is the hypothesized value, so it's the value that shows up in your hypotheses. So mu sub 0 is going to be 3.14 divided by the sample standard deviation, which is 1.11 over the square root of the sample size. Here we have a sample of 20 households, so n is going to be 20. Okay. So if you put this into your calculator, you should get a test statistic of negative 1.289. Now, then in step 3, what we want to do is we want to develop the decision rule, or we formulate our decision rule. This is a lower tail test, and so remember that if we knew the population standard deviation, then the decision rule is to reject the null if the test statistic is less than the critical value. Okay? And the critical value in that case would be negative z sub alpha. Okay? But here we do not know the population standard deviation, and so our decision rule will then be to reject the null if the test statistic is less than the critical value, and the critical value here will be negative. Again, we're going to use the t distribution with n-1 degrees of freedom. So we're going to have t sub alpha with n-1 degrees of freedom. Okay. Here we're testing at the 0.1 significance level, and so we will be looking at t sub 0.1 with 19 degrees of freedom. So what you want to do is essentially, if you have the t distribution, you want to find the t value such that the area to the right of it is 0.1 when the degrees of freedom is 19. So we want to go to our t table, look at row 19. Okay. Then you want to look under column 0.1, and that gives us a t value of 1.328. And so our critical value will then be, so this is 1.328, and so the critical value is going to be negative 1.328. Okay, so that means that we reject the null if the test statistic is less than the critical value, which is negative 1.328. Our test statistic here is negative 1.289, right? That's what we calculated in step 2. So then you'll be asking yourself, is negative 1.289 less than negative 1.328? And the answer is no. And so our conclusion in step 4, the conclusion is to not reject the null. Because the test statistic is greater than our critical value. And we do not reject the null at 10% level of significance. Okay. Again, for this type of problem, we will only look at how to do it using the critical value approach, because it is impossible to use the p-value approach. The reason it's impossible to use a p-value approach is that you cannot find a specific p-value without using a computer. Okay. So in this video, we learned how to do a lower tail test when we do not know the population standard deviation.